play. Okay. All right. Hey, so I'm going to take my mask off too. Is that okay? Far away?
No.
So we have a climate test. There's a few things that are involved when we talk about climate. And you guys did all of your work in Discovery, those 3 kind of chapters where you learned about these things. But if we're really going to understand everything, we kind of have to go back to what did we talk about before climate? What was our unit before we talked about climate? We did weather. Awesome. And when we did weather, something we did the very first week we came back is we made those hot air balloons, right? And we talked about air, right? Because it's a huge part of our climate. So if we're going to talk about air, we have to understand how air masses work. And there's certain air masses out there, right? There's warm air masses and cold air masses. Or you could talk about pressure, and you could say they're high pressure or low pressure, right? So, warm air, does it rise or fall? It rises. Warm air rises. And why does it rise?
Because its density has low pressure.
Good, because its density, it has less density. It's not as heavy, and really it's because it has low pressure. Remember? Low pressure.
Yeah, low pressure.
Yeah, low pressure. You're right. Okay. So warm air, so climates where there's warm air, it's going to be rising and it's going to have low pressure. Remember we talked about high temperature, right? Warm air is high temp and then low pressure. They're opposite. Pressure and temperature are opposite. So if you have high pressure, you're going to have colder, lower temperatures. If you have high temperatures, you're going to have lower pressure. They are opposite each other. And that's important for us to understand climate. And it's part of what's on your test as well. Okay? So if I have cold air, I say cold air mass, it's going to fall, right? And so that's why we have air as it rises. As it rises, it cools, and then the air gets more dense. And what does it form? It forms clouds. And then it gets heavy and it rains, right? So that's what's happening when we have warm and cold air masses that meet. One comes under the other. It rises, it cools, and we have this storm or rain or precipitation, right? So cold air masses, they're going to fall. They have high pressure, and that's why they're falling, because they're being pushed down. And if you think about it, we talked about this, it's more stuff, so it's heavier. So it's going to fall, and then these are low temperatures. Okay? And that's important for us to understand when we talk about climate. Okay? Because the air around the equator, is it warmer or colder? Is the air around the equator warmer or colder? It's warmer. She's fine, she'll get up. It's warmer, right? So, that means that the air around the equator is going to get warm from the sunlight, and then it's going to rise. So what is going to be happening around the equator? A lot.
Lots of rain.
Lots of rain. Lots of rain and humidity. So that's the one thing we didn't talk about. But high temperature equals more humidity. And then low temperature is going to be less humidity. Okay? So in the Arctic, where it's really cold, there is snow, but there's not rain. Right? And I don't know if you know this, but snow is not as wet as rain, usually. It is around here, but like when you go up into Alaska, the air is really dry. Has anybody ever been skiing in here? Yeah? So the air is drier, and so you can get like a chapped face or lips really easy. And so a lot of times you'll wear Burt's Bees, or you'll like cover your whole face. Right now we're all covering our whole face. Yeah, and goggles. That's because it's drier air. Huh? Well, that's the same thing. Same thing. So that's air. That's a big part of what we've learned in weather that helps us understand climate and weather. Okay? So how is climate and weather the same? How is climate and weather the same? Garrett?
Talking about what's happening, like with, we're talking about what's happening, like kind of with the temperature and precipitation.
Money. Yeah, exactly. If it's climate, if I'm looking at climate or weather, it doesn't really matter. I'm going to describe it with temperature and precipitation. That's how I describe it. Now, those two things don't determine the climate, but that's how we describe the climate. It's also how we describe the weather, right? So if I'm going to talk about the rainforest, it's warm and wet, right? Lots of precipitation, high temperature. If I'm going to describe the desert, it's hot and dry, high temperature, low precipitation. So I'm describing our climates based on, or really we had, our climate zones were polar, temperate.
Tropical, your video got interrupted.
By,
By like the little power mode thing.
oh, bummer. Did it stop recording?
Oh no, it was right.
It was still recording? That's okay. Stuff happens. Right. So we got temperature and pressure or precipitation. That's important. But there's a difference between climate and weather. What's the big difference between climate and weather? Elena.
Climate is the average time, the average weather of a long time.
Yes, and weather is?
Just the average per day.
Yeah, look out your window, right? Whatever you see, that's what's going on. So the weather can change in a day. The climate
Takes a while.
takes time if it's going to change, right? So climate is, this is the average AVG over time. This is the long term, right? And then weather is out your window. And this is short term, right? Can the weather change in 10 minutes? Yeah, it can stop raining, but the climate's not going to change. The climate's not going to change. Okay, so that's the difference between weather and climate. They're both based on temperature and precipitation, but climate is the average over time, and weather is right now. Okay? Okay, so what determines climate? Lots of things. Garrett.
One of the things is how close or far it is from the equator.
Yeah, what do we call that? How close or far it is from the equator has a name. Latitude, right? So the latitude determines it. And we say latitude, that's up and down like a ladder. When we say latitude, we're talking about a ladder. You go up and down a ladder. So north and south, where you are, north and south, that's going to determine your climate. What about longitude? Does it determine your climate?
No.
Not really, right? Not really. Because that's just going left and right across. So, right? It might determine your weather at some point, but if we go on this planet here, there's going to be a bigger difference between point A and point B than point A and point C, right? Y'all see that? These are going to have similar climates. These are going to have very different climates, right? So latitude, what else? What else determines climate? Elevation, yeah. elevation can determine climate. Right? Because, dropping my marker. Because elevation, when you're higher in the air is different. So how high I am is going to have that factor where the air masses might be different. That's going to affect my climate. Okay, what else, Elena? Pressure, good. How does pressure determine my climate? What'd you say? Yeah, it kind of determines how the air behaves, right? So if I have pressure, I could talk about pressure, but really I'm also talking about humidity and ultimately air, right? So if I have low pressure, I'm gonna have more humidity. High pressure, less humidity. Okay, we have three climate zones. What are they called? Up high? Isabella? Polar, up high. Temperate's in the middle. And tropical is around the equator, right? Good. Now, if I go south, that's just opposite. The poles are farther down, farther south. Temperate's in the middle. And then tropical is in that equator region. So we have three different climate zones, right? Now the last thing is ocean currents, which we haven't talked a lot about, but how can ocean currents affect your climate? What do you think?
Oh, like if you're on the coast and it can affect the air and like the weather and
Excellent. So it's going to affect areas on the coast near the water, right? So if I have an ocean current that brings warmer water near my coast, is that going to make my climate warmer or colder? Warmer. Good. Just think about it. It's just like heating. You're putting more energy into something that's going to have a higher temperature. So on our east coast in the United States, there is a warm ocean current that pulls warm water from the Gulf up the coast. So it's warmer here, right? So we can have beaches all along. In fact, there are beaches like in New York area where the water is really in the summer is warm enough to go out and hang out in.
Isn't it cold though?
Yeah, eventually, but in the summer it's not necessarily. Now, on the West Coast, have you ever been to the West Coast? It's kind of the opposite, right? There's actually colder air, colder water, ocean currents that flow up here. And so even though you're in San Francisco or even LA in Southern California, San Diego, the ocean water is a lot cooler, and that keeps the climate cooler on the coast. That's why in San Francisco it's pretty much 60, it's like 70s hot. 70s hot. No, it actually stays pretty cool because of that cold ocean water that keeps it cool air, okay? So that's it, climate study. See you guys pack up.